My name is Paul Lenz, and today we're going to talk about graphing in 3 dimensions. In an arithmetic, the x-axis is the one that's coming out at you. The y-axis, in this case the red, is the one that's going horizontally, and the one that goes vertically happens to be the z. Now your eyeballs are pointing this way, where this happens to be a horizontal plane. Now from that standpoint, we have to understand that we have 3 different planes. And as you can see from the drawings, we have 3 planes. Now again, we have this particular plane on the bottom which comes out at you, and it happens to be the XY plane. A plane which would go this way, which would be parallel here as well as parallel in the back, happens to be the YZ plane, and the one that comes vertically this way, which would be the XZ plane. Now, we would have a point in this case, and we would like to plot that point in 3 dimensions. Now remember, we're drawing a 3-dimensional view on a 2-dimensional piece of paper. So we would like to plot that point, and we're going to plot the point -5, 2, 3. Now if we have the point -5, 2, 3, we would like to bring an x-axis out. We would like to take a y-axis, and we would like to bring a z-axis upward as far as that. Now, when we plot the point -5, which in this case happens to be an x value, we would like to go backwards 1, 2, 3, 4, 5 units, and that point right there happens to be the point -5, 0, 0. It's not up or down anything, it's just back 5 units. When we take the next value, which in this case happens to go over, and in this case I would like to go over 2 units. I'm 2 units in a y, but I'm not 2 units vertically, I'm 2 units as far as a parallel, because I've come over 1, 2 units, and this point happens to be the point -5, 2, 0. I'm at -5, 2 on an xy plane, and I'm not up or down anything at all. The last value would be a value of 3, and again we're going to come up 1, 2, 3, but we need to come up 3 from that particular point, which is -5, 2, 0. So we're going to come up 1, 2, 3, and that value right there happens to be this value, which is -5, 2, 3. Now, on the next set, we would like to take a look at a coordinate box. That coordinate box has 2 opposite vertices. One is the origin, which happens to be the point 0, 0, 0, and the other value happens to be the point 5, 4, 2. Now, by opposite points, we mean one value would be back here at the origin, and the other one would be in the opposite corner. In other words, one is lower corner, and the other one happens to be an upper corner. So let's plot that rectangular box. We have a point 5, 4, 2, and we're going to come up an x-axis of 5. We're going to come over and take a y value, in this case of 4, and we're going to go a z value of, in this case, 2. Now, first going to come out 5, 1, 2, 3, 4, 5. We're going to have it's going to be a corner, as well as this corner back here happens to be the origin. We would like to come over 4 units. So in this case, we're going to come over 4 units, and as we come over 1, 2, 3, 4, this becomes a corner, and so we're over 1, 2, 3, 4 to here. Now those 4 points that we have drawn right now happen to be the bottom of the box. So now we would like to go up value of 2 units, and as we come up 2 units, I'm going to come up 2 here, and that would be that particular point. I'm going to come up 2 here, which would be this particular point. I'm going to come up 2 here, which would be this particular point, and I'm going to come up 2 here to that particular point. As we draw that particular top of the box, we now have a value which goes here, across, over, and across as far as that. So that blue line represents the top of the box, and in this case we will draw a green box which would be here, or blue, another one again, as far as the bottom of the box. We're now going to talk about planes, which in this case would be something that might be parallel to a particular axis. The first one we're going to look at is equation 2x plus 4y equals 12. Now in this equation, z can represent any number at all, so therefore the plane becomes infinitely upward and downward and is parallel to the z-axis. The x-intercept would be the point 6, 0, 0. The y-intercept would be the point 0, 3, 0. And what we have shaded is in the first octant, in other words, where everything is positive. The second equation is 2y plus 3z equals 6, in which there is no x value, which means that this plane happens to be parallel to the x-axis. Now the intercepts happen to be the point 0, 3, 0, as well as the point 0, 0, 2. There happens to be those particular line in which x represents all real numbers. The value of y is in this case 0. In other words, I'm not to the left or to the right any degree, and my value of z is 2 for that particular line. Now in the third equation we're looking at, it is 3x plus z equals 6, and there is no y value. Now that means again that this plane is going to be parallel to the y-axis. The x-intercept happens to be 2, 0, 0, and the z-intercept happens to be 0, 0, 6. This one has a line which would be in this case on the y-z plane, and in this case x is equal to 0. The value of y can represent all real numbers, and the value of z is equal to 6. The third equation is one which intersects all three axes. In other words, the equation x plus 2y plus 3z equals 6. In this case, the x-intercept is a value 6, 0, 0. The y-intercept is a value 0, 3, 0. And the z-intercept is a value 0, 0, 2. And you can see the three lines which are on those particular planes. The one equation, x plus 3z equals 6, when y is equal to 0, would be on the xz plane because the value of y in all cases is actually equal to 0. The one that's on the upper right would be 2y plus 3z equals 6, and x is equal to 0 because that line is not towards or away from you as far as from the origin. The third one is a line x plus 2y equals 6, and z is equal to 0, and that happens to be on the xy plane, and it's not up or down anything at all. Now in summary, what we've talked about today is putting a three-dimensional figure on a two-dimensional plane. In mathematics, the axis which is coming out at you is the x, the one that goes to the right is the y, and the one that goes up happens to be the z. The coordinate triples are designated x, comma, y, comma, z.